Okay, let us start the case when we have bilateral. Most questions I think we've been seeing that I've been considering them when they are horizontal. Now, let me handle this when I'm combining a hemisphere and a conical solid, but when they are in a vertical shape. Okay, so we are going to use these ones as you saw in the previous lessons. We always let W be the weight per unit volume, because if we are dealing with solids, we always get the volumes, which is unlike when we are dealing with laminars, when we have to get the area. So here I say the question is find the center of gravity of the uniform composite pattern below, formed by combining a conical and hemispherical solids as shown below. A conical, you see this is the hemisphere below there. So what we are going to do, in order to get the center of gravity, we need the weight of these two solids and where they act. If we get those points, then we use our formula with ease. So this one is going to give us volume 1, and this one is going to give us the second volume, volume 2. So to get volume 1, I'll get, you see volume 1 is a cone, so it's a 30 pi r squared h, the height. So our volume 1 is going to be a 30 pi into r squared. You see the radius from here up here is 6, so mean the radius is 3. So 3 squared times the height. So the height from here up here is 4. So this one is going to go with that. So it's that our volume 1 is going to be 12 pi. So we take this 12 pi meters cubed. So meaning now our weight, how do we get the weight? Because the center of gravity deals with weight. To get the weight, we say you get the volume times the weight per unit volume. But we say, let W be the weight per unit volume because we don't know it. So that if it's that, then we shall be getting now the volume for this, then times the weight per unit volume. So 12 pi, then times W, and that will be our first weight. For the second weight, we have the hemisphere, V2, and the hemisphere. You know, if you get a hemisphere, its volume for it is going to be 2/3 pi r cubed. It's a half of a full hemisphere. So for a hemisphere it's 4/3, but for this one is a half of there. So our V2 is going to be 2/3 pi into 3 cubed. This is 27/3. 9 times 2, that is 18 pi meters cubed. And so our second weight from here is going to be, get now the volume times the weight per unit of H, and this is going to be our second weight. Then our total weights of the whole now solid. When you get this and this, when you combine them, you shall get 12 pi W plus 18 pi W. This is going to be 30 pi W. Okay, now it's not giving us where we are going to determine. But you see, this thing is metric about the particle. It's metric about the particle. So we are going to consider, since the solid is symmetric about the vertical axis, then of course our center of gravity, y bar, all we need the sum of weight I, xi over yi over summation of wi. Now, because symmetric means that even the x values are going to be the same. So, in some cases, we see that people don't just find y only. Because if it's symmetric about the y, the vertical axis, means that all the x values are going to be the same. So that's why, if you don't want, you can just get the yi only. As simple as that. Now, what I'm going to do, I'm going to draw also. You see that symmetric there? So also what I'm going to do also, I'm going to draw a vertical axis here. As you can see there, I'm going to draw my vertical axis there. And then I'm going to get a horizontal from here, which I'm going to call AB. So that. So now, this is the vertical, and this is the horizontal axis. We said they should be perpendicular. Now, our task is to get the coordinates of the center of gravity of this, and which we are going to call V1. Then you get also the coordinates for the center of gravity of this, which we are going to call V2, because we have already the weights for each. Now, we say that for the cone, if you have this, the center of gravity, now you see this one is above the horizontal, so it's going to be, now we are going to get our center of gravity from here, from this vertical axis. You start all of them, of course the horizontal, from here up to here is R, and this is going to be R. So first of all, this one is going to be R. Then for a cone, the R for R, which is going to be 3 meters, and this is 3 meters. So this is also going to be 3. From here up to here, it's going to be the X there. Then we need to get this. But for a cone, we know that from here up to here, to get this height from here up to here is pi is h, the height over 4. This is going to be from the base, from here up to here is h over 4. So which will get our height, which is 4. Our height we see it is 4. Then over 4, which is going to be a 1. Why? Because from here up to here is a quarter of the height. A quarter of the height. So this is our height. From here up to here is 4. So that's why this one is giving us 1. Because we know this distance here is a quarter of the height. Now, when we come to this, of course, from here up to here, from here up to this center is going to be 3. But the y from this is going to be negative because it sits below. It's going to be below. So that's why I'm going to say this is going to be negative. But to get this distance 100 is going to be 3 over 8 times the radius, which is 3. But it's negative because, and so our get to here is going to be 3, comma, then negative 9 over 8. Negative because it's below the horizontal axis. Horizontal axis. We consider this horizontal axis because always to get the center of gravity, you are sure you are going to be, you need the vertical, you need the horizontal. As simple as that. So you see that always our if it's symmetric about the vertical, always the x values are going to be the same. If it's symmetric about the horizontal, then the y values are going to be the same. As simple as that. So that's why here you can just get only the y, because even the center of gravity is going to act on the line of symmetry. Always the center of gravity is acting on the line of symmetry. And here we are seeing that the x value is 3. So meaning even for the center it's going to be 3. Anyway, so we have here, but we have the weight for this. This is our coordinate, but this one is holding the weight 2, and this one is having weight 1. So to get now our x bar, y bar, of course we know that x is going to be 3. Anyway, we just as you can see, we are going to be getting w1, then the coordinates, then plus w2, then the coordinates, where that w2 is, then the sum of the separate weights. Then from there, our x bar, we just substitute. It's going to be our weight 1, 6, 4, 5, w. Where is it acting? It's acting at 3, 1. Then plus our weight 2, which is 18, 5, w. Where is it acting? It's acting at 3, negative 9 over 8. Then the whole we divide by these two weights. 4, 5, w plus 18 by w. And then after simplify that. That is going to give us, with ease, this is going to be 12 times 3 plus 18 times 3. So the first answer I'm getting 90 by W. Now all over, then this one, you just say this is 1. Then the other is negative 9 over 8. And so here I'm getting this is 33, negative 33, the whole over 4 by W. Remember, we are dividing with this 30 by W total weight. This will give us, of course, 95 W over 30 pi W. Then we also get this negative 33 pi W over 4 divided by 30 pi W. So that these are going to cancel. Even these ones are going to cancel with this. So our x bar, y bar from there is going to be, up we have 3. That is obvious because we told you from the start. Even the center of gravity is going to be having the same coordinate of x if it's symmetric about the pattern. Okay, then this one we are having negative 11 over 40. Can't we simplify that? Negative 0.275. So therefore, you see, or you can say the center of gravity is you see this one, it means that it's below here. So you can say it's this below the horizontal. You can say it's 0.25 meters below. Negative means it's below from the horizontal. Therefore, the center of gravity is at 3, negative 0.275. Or you can say it's at 0.275 meters below the horizontal, as simple as that. So that's our case we have there. I wish you will analyze. Okay, that's it. Now don't forget subscribe. But the idea is, by the way, all these formulas to get the, you know where the center of gravity is going to be acting, they are derived from integration. Yeah, they are derived from integration. All these are mathematical, mathematically worked out. So all these ones, you get them integrate by integration from this, and so on.